Question 13. Juliana plans to invest money for 10 years in an account paying 3.5% interest compounded annually. She expects the annual inflation rate to be 2% per year throughout the 10-year period. Juliana would like her investment to be worth a real value of $4,000 compared to current values at the end of the 10-year period. She is considering two options. Option 1, make a one-time investment at the start of the 10-year period. Option 2, invest $1,000 at the start of the 10-year period and then invest X dollars into the account at the end of each year, including the first and last years. Okay, part A asks for option 1, determine the minimum amount Juliana would need to invest. Give your answer to the nearest dollar. Okay, so let's take in some important info. So we've got 10 years here. 10 years is our time frame. We've got 3.5% compound interest compounded annually in the account. And we've got an inflation rate of 2% per year. Annual inflation rate of 2%. Yeah, okay. Throughout the 10-year period. Okay, and very important bit of info here is this idea of a real value of $4,000, okay, compared to current values. And we need to find the minimum amount for option 1, minimum amount Juliana would need to invest such that she has this real value of $4,000 at the end. Okay, so for this, we will need the compound interest formula, which is in your formula booklet, and I have written that down here. Okay, so where this FV stands for future value, PV stands for the present value, R is the interest rate, okay, as a number, all right, not converted to a decimal or anything. So if the interest rate is 6%, you put 6 in here, okay. That's dividing by 100 is the thing that converts that percentage then into a decimal, right? So you don't have to worry about converting the interest rate into a decimal. That's the formula kind of does that for you. Yeah, so then divided by 100K, and K is the number of compounding periods per year. So in the AI course, you will have annually, half yearly, monthly, quarterly, and then monthly. Okay, so those are the 4 options. So that means K can take the value of 1, 2, 4, or 12. Okay, so for the most part, then there could be variations on that, but for the most part, those will be the 4 main options that you'll get. And now that's raised to the power of K, which we just talked about, multiplied by N, which is the number of years. Okay, so for this question, the tricky part comes into play when we have this idea of the real value of 4,000. Okay, and essentially what that means is we're going to have to adjust this future value for inflation, okay, for this 2% inflation. Okay, so therefore our future value in this equation here is going to be our 4,000, but then adjusted for inflation, which is 2%. So then that's going to be 1 plus 2 over 100. Now we were told it's annually, so K is going to be 1. I'm going to put 1 in here just so you can see what would happen if, let's say, if K, so if K is 1, you don't have to put this in, you don't have to put the 1 there. Though if it is not, then you definitely, I would say remember it. So that's why I'm going to be quite pedantic here and put everything in. And then this is going to be raised to the power of 1 multiplied by 10. Okay, so just basically 10. And this is going to equal the present value, which we're trying to find, okay, multiplied by our interest rate, or our annual interest rate in the bank account where she's investing the money, which is 1 plus, so the interest rate was 3.5% divided by 100. So again, I'm going to put 1 in there, although it wouldn't be necessary for you to do that in your exam, and yeah, there we have our formula. Our equation. Now we just have to rearrange this for the present value. Okay, and so the way we'll do that is we'll say PV, the present value, is going to be equal to 4,000 multiplied by all this, but I'm going to take this and we can clean it up. Let's get rid of the ones and to the power of 10. Let's make this smaller, bring this over to here. Okay, all right, and then divided by this here. In fact, I will actually show you what this will turn into if we were just to write it as a decimal. So 1 plus 2 over 100 to the power of 10, we could change to being 1.02 to the power of 10. Okay, so just to show you, this thing here, what I've just written, is the same as this bit here, right? It's just sort of cleaned up a bit. And all right, and now then this is going to be divided by essentially this, what I've just brought down here. Okay, but then if I want to make that slightly cleaner, what we can do is call it 1.035. Now let me bring that down. I've got no room for my power, to the power of 10. Okay, cool. And so there we have our present value calculation. And so if we put this into our calculator, we will get 4,000 times by 1.02 to the power of 10 divided by 1.035 to the power of 10, which gives us an answer of $3,456 dollars and 67 cents, let's say. But what we'll do is we'll write 3,456.67 and then rounded to the nearest dollar as we're told. And we're in dollars, so always a good idea to put the unit in as well. So we'll say $3,457. Okay. Now, quickly before I move on, I've noticed that an alternative way to calculate this, which is accepted in the mark scheme, though is technically slightly wrong, is if you just take the difference between the inflation rates, okay, which would be 3.5 subtract 2, okay, which would give us 1.5. Now, if we do that though in our calculation here, and we go sort of 4,000 divided by 1.015 to the power of 10, you'll see that gives us $3,446, okay, dollars. So it's very close to being correct, though it is slightly off. But I will say that this is actually an accepted answer as well in the mark scheme. Both of these were accepted. The one that I've done here is more accurate, though that method there is also accepted. All right, but yeah, we're going to stick with this because that is more precise, more correct. Okay, so let's move on to part B. All right, for option 2, find the minimum value of X that Juliana would need to invest each year. Give your answer to the nearest dollar. Now, in order to calculate this, you're going to need to know how to use the finance solver on your calculator, on your GDC. Okay, so same again, it'll all be, every calculator will be slightly different, although the process and the fields in which we need to put our values will be somewhat, they'll be similar. They'll be similar, but the process on how to get there could be different for each calculator. So if you're unsure on how to do this in your own calculator, just follow a YouTube tutorial or Google it, and there should be something up there that should help you out. Okay, so over to the calculator. So on this one, we need to go to the financial section, okay? And then we get a list of all these different financial applications we can use. So for this question, we need, and for the most part, what you'll be using is the compound interest function here. Right, and so here we have a list of inputs that we need to put in. So you'll always leave one blank because that's the one you'll be solving, okay? So N stands for the number of payments, okay, made throughout the whole period, okay? And in this question, we're told that she is making annual payments for 10 years, okay? So that means there are 10 payments, right? So if, just to give you a different example, if it was, let's say, quarterly payments for 10 years, then the number of payments would be 40. Okay, it would be 4 payments every year for 10 years. But for this one, we've got annual payments for 10 years. Now, our interest rate was 3.5%. Okay. The present value, okay, so the way we need to now consider the present value and the future value of what we need to put in is we need to think about it in cash flow terms. Okay, so at the start, our question says that our option 2 says she'll invest $1,000 at the start of the 10-year period. Now, if we're thinking as if we are Juliana, okay, that means we are paying $1,000. Okay, so what we're going to put in here is negative 1,000. You can think of it as if you were the bank. Let's say you could say you're the bank and you're going to be receiving it, but just make sure that for the next terms that we talk about, that you keep the same frame of mind, whether you're coming at it from the perspective of being bank or being Juliana. I tend to stick with the person or the subject of the question, which is Juliana, and so she is paying $1,000 to the bank at the start. Okay. And the future value here, right? So this is what we were calculating before, all right, in our part A, which was the $4,000 of real value. So hence real value, aka adjusted for inflation, which will mean we need to multiply this by 1.02, which is the inflation rate, to the power of 10. All right. So then now that gives us the future value adjusted for inflation. She invests $1,000 at the start, so that's the present value of the account. Got the interest rate, number of payments. Then another thing you're going to have to make sure here, which is on this calculator, it's a little bit hidden, but you're going to have to make sure that the payment date is the same, okay, or is correct. So in option 2, we were told that she invests $1,000 at the start of the 10-year period and then invests X dollars into the account at the end of each year. Okay, so that means we have to put end there, all right, rather than begin. It'll be quite clear if it is begin because it will say beginning of each year. All right, and so there we go. And now we've got to go to the payment bit and put solve. And there we have our answer. Okay, so negative $295.39. This negative bit means that Juliana is the one paying the bank. Okay, if we wanted to come at it from the perspective of the bank, okay, if we wanted to think we're the bank, the future value is going to be what we pay to Juliana. So we'd have to put that as a negative, and we'll put the present value as a positive. All right, because that means we're receiving it, we're the bank. All right. And then if we solve this, you'll see what have I done over here? The same amount comes up, but it's positive. Okay, so that's what kind of thinking of it as if you're the bank and you are receiving these $295 payments, right? So you can come at it from either frame of mind, but you just have to be consistent between the two. All right. And the inputs that you're putting in. Now let's so here we have the answer is 295.39. Okay, so let's come over back to the pad. And here we are. Cool, very nice. And so using our finance solver, actually what I might do is I'm gonna take a screenshot here for us. Let's plug it in. Okay, there we go. And so therefore, the payment is equal to $295 rounded to the nearest dollar. Okay, there we go. And I didn't talk about these but here, but this is the P/Y is payments per year. Okay, so that's one. And C/Y is the compounding periods per year. Okay, so both of them stayed as one. Yeah, I hope that helps. And yeah, all the best. That is the answer to question 13.